All right, let's jump right in. We're talking about something pretty huge in the world of AI today, a totally new way for it to tackle really complex problems. It's called chain of agents. So here's the question that's been nagging researchers for a while now. When you've got a problem that's just way too big, too messy for a single AI mind to wrap its head around, what do you do? Well, the obvious answer seems to be, hey, just build a team. You get a bunch of specialized AIs, a planner, a researcher, a coder, and have them all work together. But honestly, this whole team approach has always been kind of a mess. It's super expensive computationally, it's clunky, and getting these AI agents to talk to each other efficiently, it's a real headache. Which brings us to this really radical new idea. What if you didn't need a whole squad of separate AIs? What if, instead, you could teach one single AI to be the entire expert team, to collaborate with itself? Okay, so let's really dig into this. We're going to start by breaking down the core problem that the researchers at Oppo's AI agent team were trying to crack. Why is that old way of doing AI teamwork just so difficult? First, let's just make sure we're on the same page about what an AI agent even is. You can think of it like a single player on a sports team, each with a very specific job. You've got your planner agent, who's like the quarterback, you've got a researcher agent who's out there scouting, and you've got a coder agent, the one who actually executes the play. Each one is a specialist. And this is where the trouble really starts. When you get them all together, all that chattering back and forth creates this massive computational overhead. It just grinds things down. It makes the whole system really rigid, Hard to adapt to new problems without a ton of manual tweaking. But you want to know the biggest flaw? The real killer? They just don't learn. The team keeps making the same mistakes over and over again because the system itself never actually gets any smarter. So, of course, researchers knew this was a problem, and there have been other attempts to try and streamline this whole process. They got close, but there was always something missing, a key ingredient. Some of the earlier ideas were definitely a step in the right direction. They taught a single AI how to use outside tools, like a search engine or a calculator. But it was still a very stiff, linear process, kind of like a person just following a checklist. It didn't have that dynamic spark, that magic of a real team of experts bouncing ideas off each other. Okay, this chart right here, it basically tells the whole story. You can see how all these previous methods were always missing something. Multi-agent systems, sure, they could collaborate, but they were clunky and couldn't learn. Tool-integrated reasoning was a bit more streamlined, but it lost that collaborative magic. The real breakthrough, the reason we're talking about this, is that chain of agents is the first one to finally tick all the boxes. It's end-to-end, it's collaborative, and it learns from its own experience. The whole package. And that brings us right to the breakthrough itself. We're talking about a completely new kind of agent, one that works in a fundamentally different way, the solo superstar. So we're back to that wild question from the beginning. What if one AI could be the whole team? Well, that's exactly what chain of agents does. It pulls that entire collaborative process inside of a single, unified model. This comparison just shows the difference so clearly. The old way was this simple, repetitive loop. Think, act, observe, over and over. It's like a worker on an assembly line. But the new chain of agents model, it's a living, breathing workflow. It can plan, then decide it needs to search the web, then it can stop and reflect on what it found, then maybe write some code to analyze that data, and only then give an answer. It's like having a fluid, internal conversation between all these different expert roles, all happening inside one mind. So the billion-dollar question is, how do you actually teach an AI to do this? How do you train a single model to start thinking like an entire team? It's this really fascinating two-stage process. First up is what they call multi-agent distillation. The best way to think about it is like a rookie athlete just poring over game tapes of the absolute best players. The AI studies how successful teams of other AIs solved problems, learning all their patterns and strategies. Then, stage 2, agentic reinforcement learning. This is where the AI actually gets off the sidelines and onto the field. It starts practicing, solving problems on its own, and it gets direct feedback, almost like a coach. This reinforces the good moves and helps it learn from its mistakes until it absolutely masters that collaborative process. So what you're really doing, in essence, is taking the collective intelligence, the combined wisdom, the collaborative strategies of a whole team of experts and distilling it all down into one single powerful mind. Okay, so that all sounds great in theory. But does it actually work? Let's get to the good stuff and see how this new model, which they're calling the Agent Foundation Model, or AFM, actually performs out in the wild. First, we've got the Gaia benchmark. You can think of this like a triathlon for AI assistants, testing them on all sorts of complex, real-world problems. And as you can see, the AFM model sets a new, state-of-the-art score, blowing past all the previous top models. And it's not just good at general tasks. Let's look at advanced mathematical reasoning, which is notoriously difficult. On the AME 25 benchmark, AFM hits a nearly 60% solve rate. I mean, that's a massive 10.5-point jump over the previous best methods. That is a huge leap forward in this field. The researchers themselves really said it best. AFM isn't some one-trick pony. It is setting new records across the board, in all kinds of different areas, from navigating the web to generating complex code. But look, raw power is only half the story here. Remember all those problems with the old multi-agent teams being super slow and expensive? Well, this is where Chain of Agents really shines. Just look at this number, 84.6%. By getting rid of all that inefficient back and forth chatter between different agents, this new model cuts down the computational cost by a staggering amount. And that cost is measured in tokens, which is basically how much raw thinking the AI has to do. So we're not talking about a small tweak here. This is a game changer. It's just wildly more efficient. So what's the big takeaway from all of this? Why does it matter? It means we're on the cusp of AI that is way more powerful, but also way more accessible. Because it's so much more efficient, solving incredibly complex problems gets cheaper and faster. And the cherry on top, the whole project, the models, the training code, all the data, is fully open source. That's going to light a fire under research in this area. The most important thing to remember is that this isn't just a little step up. It's not just a smarter agent. It's a whole new paradigm, a completely new way of thinking about how we build AI that can reason and solve problems. And that's really the big question this leaves us with, If we can really pack the collaborative genius of an entire team of experts into one single efficient AI mind, what's next? What kind of challenges in science or creativity or logistics, things we once thought were impossible, are suddenly going to be within our reach?